Yeah, good afternoon dear students. Welcome to another class on data structures and algorithms. Today we will be discussing about circular linked list, one of the very important concept of circular linked list. So, in circular linked list, what happens? Linked list has two part, data part and address part. Address part will be pointing to the next node. The last node of the circular linked list is pointing to the first node. So that is the thing that you should understand. And circular linked list, every list, every element, every node has a link to the next element in the sequence, and the last element is linked to the first element. So that is the concept that you should understand. And the only difference, then many times they ask this question, what is the difference between a single linked list and a circular linked list? So the only difference between single linked list and a circular linked list is that the last node of the single linked list is pointed to null, whereas the last node in circular linked list is pointed to the first element. So that is the only difference that you can find between single linked list and circular linked list. And there is one advantage also. So one of the main advantage of circular linked list is that it allows traversal of a complete list from any of its node, which is not possible in single linked. Single linked list, always you have to start from first node, you have to end at last node, that's all. And you cannot traverse again and again. Whereas in circular linked list, you can traverse according to your choice. That means you can retraversal. So you start from the first, you can visit the nodes any number of times. Whereas in single linked list, you can visit only one time. That's all. So that is the main concept that you should understand. And what are the operations involved in this circular linked list? There are four major operations: insert, delete, search and print. Insert operation. So as you know, you can insert at the end of the linked list. Delete operation, you can do either front delete or end delete or in between no delete. Search operation, you can search anywhere. And finally you can print also. Printing, you can print all the nodes starting from first node to the last node. So that is the thing. Now, insertion operation. If you want to insert, you observe there are two special pointers used. One is the head pointer and the one is last pointer. Last pointer is pointing to the last node of the circular linked list, and head pointer will be pointing to the first node. Now, what happens if you want to insert a new element? This I want to insert. So what happens? If you want to insert, what happens? This is a new pointer, that is PTR. You call it as PTR. You observe this first line. Last pointer's next link, you make it to PTR. So what happens? This gets activated. This line gets activated. So what happens? It is going to have first this is going to execute. So the last pointer no link will be pointing to PTR. This first concept is done. Second line is that PTR next is equal to head. So this PTR is the new element. PTR next is equal to head. So it is automatically where is head pointing? Head is pointing to this first link. So what happens? This will go to link to this So this is the second step. The second step is this, and this is the first step. So in the first step, the last node is connected to PTR, and second step, PTR's next you connect it to head node, that is first node, and this last pointer you move to PTR. So last is equal to PTR. So this is the concept that you have to understand during insertion of a node during circular linked list. So last node next pointer you point to the PTR, and PTR you point to first node, and move the last node to the PTR. So what happens? Automatically old link will terminate, the new link will come. So this is first node, second node, third node, last node, because this last is moved here. So last is now pointing here, LAST, last is pointing here, last node is pointing here. And these are the 3 steps operation that you have to do it for insertion operation in circular linked list. Now the same thing it is given in your textbook as algorithm, whatever I have explained so far, same thing. So what you are doing here, you are trying to allocate the memory for a new PTR, and you call it as PTR, and PTR value you just store it and everything. If the first is null, what happens? First is null means, so what is the instance? So no element in the linked list. So in that case, what happens? This is the first element, and this element will be automatically moved on to step 5. So PTR and PTR is first is equal to PTR, and last is equal to PTR. PTR and next is equal to first. So what happens? There is only one link, and you have some value. Value is something like 3, and this pointer is pointing to itself. And for this only you have the last link. You also have the last link, LAST, last link is also present in the last pointer is also present, and the first pointer is also present. You can see last pointer and first pointer also present in the same node. If there are any nodes, what happens? The new node, whatever you have, for this new node, this last will be connecting, and from this it is connecting to the first node. So you discard. Same way, if you have one more link, one more node, what happens? The last node's link will be connecting to the new node, and the new node is connecting to the first node. So meanwhile, you will be deleting the previous nodes. Automatically you will be deleting the previous links. So like this it will happen. That is what whatever I have shown in the previous, the same thing is explained in algorithm. Algorithm is what? Step by step procedure. Next, deleting a node. So deleting a node is quite interesting. So the delete operation in circular linked list is performed in the same manner as that of in single linked list. What you have to do? You have to ask the user the element to be searched. So whatever the element to be searched, what happens? It will be searched, and you will find the location of the element, whether the element is present in the first or in the last or in between. So you understand where exactly the element is present. Based on that condition, so you can remove that particular element. Of course, if the element is present, suppose I want to delete the first element. So I am looking for the element which is to be deleted. It is 10 is the element that I have to delete. 10 is the element that I have to delete. So what I have to do is very simple. So this is the initial condition. This is the initial condition. So remove the first element. So if you want to have the first element, sorry, this is a condition. Or if you have the condition like this, So if you have a condition 99 is connected to 11, 11 is connected to 22, 22 is connected to 33. So I want to remove 99. So you have header node is present, you have last node you have here. So now what you have to do, you have to move the head node, you have to move the head node, that is first node, to the first node of next. So that means it has to move the current node, that is head node, has to be moved to the next. So that is the first thing. That is the first thing. And previous node, earlier it was pointing to head node. So this has to be pointing to the that is current nodes of next. So this has to be moved. After this, you have to delete this. So you have to delete this. So that is what you have to understand. So 99, 11, 22, 33 are the initial values. If you want to delete the first element which you want to delete, so what you have to do is you have to move the current pointer to the first element. From the this point, you have to move the header node from the current pointer of next. Current pointer of next you have moved. First thing. Second point is the previous node which was pointing to the current node. So this has to be moved to the current of next. So it is moved. And later you have to delete. So that is the first thing. So after deletion you will get a linked list like this. Now you have to remove the last element. So look at here, normally it will be displaying like this. The initial array will be like this. Initial data array will be like this. And you have to delete the last element. So last element is 44. So 44, the last link, it is present to the first link. So what you have to do, you have to find the element which is to be deleting. So you move the current pointer to this. So what you have to do, the previous pointer which has to be moved to the head, and automatically what happens, it has to be deleted. So this has to be deleted. There are only one operation. First you move the last pointer to the first, and you delete it off. So that is the only thing. After removal you can find this. Same thing if you want to delete in between. Very simple. So this is the node that I want to delete. So very simple. You move the current pointer to the previous to the deleting pointer. So what you do, you move this next pointer to the next of next. So you move here, and you delete this element. So it's finished. So the same kind we have seen deletion operation in a single linked list. Same way it has to be done. And displaying is very simple. You start from the first node, you go until the last node. So display all the elements and finally close it. So that is the thing. The algorithm also talks about 16 steps are there. So you can see if there are only one element, so you can delete that entire element and make first pointer, next point, last pointer null. So you have to do the same thing. If there are multiple, if you want to delete the last element, so if you want to delete the last element, so what you have to do, you have to move to the temporary of next is equal to first, and then you have to remove that element. If you want to remove the in between element, so what you have to do is the temporary element has to move to the next previous of the last element, and it has to delete. So all these things they have explained in the steps. Same thing I'm just telling. And searching and printing, it is another operation. So the search operation in a linked list, circular linked list, is performed in the same manner of singly linked list. What you will do, you will start from one element, that is header node, and you try to check for the value for the key element, you compare. If it is found, you just say it is found, and you reach the last element and still you have not found any element. Finally, you display unsuccessful. So you can certainly, same thing print also. The print operation in circular linked list is performed very similar to your singly linked list. You start from the header node, and until you reach the header node, you keep on printing the elements. That's the simple concept. So you have to do it. So the same program I have just already coded, and it is ready. So I'll be just opening Notepad++. So it is already there. I'll just show it. Yeah. So again, this program I have taken it from your textbook. So you include two header files, std, stdlib.h. Create a structure node, basic node structure. So you have two components. One is info, another one is link. That is next, link to the next. And you create two pointers, first and last. First and last, initially they will be null. No linked list is there, it will be null. And you use four functions: insert, delete, and display, and search. Search returns the location of the searching element, okay, where the element is found, because that is searching element is mainly used to delete. So you have to use it. Now num1, num2 are two numbers generally used inside, and choice is the for menu choices we'll certainly use this. And you use another pointer that is location, where the location of the searching element you can certainly store it. Okay, so now you display the menu. Before that, you create a while loop. While one is nothing but true. So this while loop is a continuous while loop. So until you choose exit option, so it will keep on looping. And 1 for insert, 2 for delete, 3 for search, 4 for display. So it is just like that. And anything other than 1, 2, 3, 4, 5, 4. So what happens? There will be an exit. So in this case, so enter your choice. So you are asking the choice, and you are creating a switch statement. If case is 1, so please enter the element to be inserted. You check, you ask for the element, you scan the element, and you send it to insert function. Same way, enter the deleting element, you take the deleting element and you send it to delete. Same way, searching element, enter the searching element, you send it for a search function, and search function is returning some location value. If the location value is null, you can certainly display a message, element not found, or element found, you can certainly display. And choice 4, there is case 4 to display. Display function, you just call it, and anything other than 1, 2, 3, 4, default return from the main function. That means exit from the program. So this is what the main program. In the insert, what happens? Look at here. So you are passing the data that is to be inserted into the circular linked list. So you first create a new node called PTR and allocate the memory and store the memory. PTR of info is equal to data. Whatever the data that is passed to the insert function, you store it. The linked list node is ready. This node you have to insert it into the linked list. Now you check whether first is equal to null. When first is equal to null, so whenever there is no linked list, so there is no circular linked list, so it is not yet created. Whatever you are creating is the first. So in such cases, what happens? First will be null, and in that case, what you do? First is equal to last is equal to PTR. So the first node, whatever you are creating, PTR will be the first node, the last node, and PTR next is equal to first. So you do this, and that's it. You can done. It is done. So there is, if it is the first element, if it is the first node, if it is the first node, else already some nodes are available. In such cases, what happens? So last of next is equal to PTR. Last of next, the last node which is there in the linked list is called last pointer. Last of next is equal to PTR, and PTR next is equal to first, and last is equal to PTR. The same thing that we have seen here, I have explained here. Same, last of next, last. So this last of next is equal to PTR. So that is what I am doing. Last of next is equal to PTR. So this link I am creating, first link I am creating. Next, second, PTR next is equal to head. So head is nothing but first. PTR next is equal to first. First is nothing but it is the header. And last is equal to PTR. So last is equal to PTR. I am just moving. So by doing this, you can insert elements. You can start inserting elements, any number of elements, and let us display. Okay, I'll just demonstrate display. Okay, display. What you are doing? You are checking whether first is equal to null. So when first is equal to null, what happens? Linked list is empty. You can certainly display a message. A circular linked list is empty. So you can display a message. If it is first is equal to last, that means it's a single element. You have only one single element. You have only one single element. So what you do? You just display the node, first node. That's all. You just display the only the first node, and you move it. So you have head in the beginning. You have head in the beginning, and you have the last. Okay. Actually, it is not last. It is head. It is not head. It is first. So first you have the data, and last. So it is the same thing. You can certainly have. If there are many elements, you start a PTR from the first node. You traverse up to the last node. Every time you display this. Every time you display node like this. Every time you display elements like this, and of course after displaying, you display the last element. You display the last point. So last element also you can certainly display. So it is, you can certainly display. So this is the code. This is the code to display all the elements. This is the code to display all the elements. In this, what you are trying to do, if it is only no element, display linked list is empty. If it is only one element, you display that particular element. If there are more than one elements, you create a for loop, start from the first and you reach until the last. You keep on executing, keep on displaying all the elements, but the last element you will display after the for loop. You finish it off like this. You can certainly do it. So now the same program, let us execute. So yeah, Turbo C++. I just demonstrate this program in Turbo C++ because it is more interactive. So, and after that I'll come back to the delete function. So delete function, I need a different delete and search function. We'll discuss little later. Okay. So first, insertion and display. Okay, I open the program. So it is there in bin and circular linked list. It is there. Okay. So you can certainly see. You can certainly see this program. Same program. So you have the structure. So you have first node, last node, and this first node and last node I have made it as global pointers so that you need not have to transfer within the function. So same, insert, delete, display and search. So delete and search we'll discuss little later. Now insert and display I'm going to concentrate. So now I just run this particular code. So I'm sorry. So yeah, return TURN, right. Right. So I just run this particular code. Now today we'll be discussing only about insert and display. Now I enter 1 inserting an element 12. So I display 4. So first 12 and last. So I have just used. So now I'll insert one more element 46. So as soon as I enter this particular element, so what happens, you can see, so 46 is inserted, 12, 46 and last. Okay. So and again, so I insert another element 45. So you can see, so 12, 46 and 45. So you can certainly see this. So the element is displaying, and of course I have placed a new line character there. That's why 45 is coming in the next line. So anyhow, so this is so, and now we will see. Now we will see the delete function. We'll see the delete function. So in delete function, what is that delete function is doing? So I was just this new line character I wanted to put here. I put here. Okay, I made that mistake. Okay, anyhow. So yes. So now delete function. What is this delete function is doing? So delete function, before we talk about delete function, let us talk about search function. You are sending a key value and you have to search it. You check if the first node is null. So there is nothing to search. You return null. That's all. If you return null, it is an indication that the search is unsuccessful. Then if first.info, if it is the element, key element, return the first. So that means you are returning the address of the element. If the address of the element, if you pass, so it is a successful. If you pass, if you return back null, then it is unsuccessful. So you start again from the PTR and you go until the last, and you try to check whether PTR of info is equal to the key element. If it is equal, you return PTR. So and you go up to the last element, but the last element you can check it after the for loop. You can certainly check last of info is equal to key. So yes, if it is so, you display the last, return the last element. So like this. So if the element is found in the last, you print last, you return the last. If element is found in the first, you return first. If element is found in between, so you can return this PTR. So this search function you are doing. So this is if nothing is available, so then it will return null. So anyhow, if it is not found in the first also, sorry, if it is not found in the first also, last also, then definitely it will return null. Okay. So this is the code for searching, and you can certainly go to delete function. Now delete function you take. So in this, actually the delete function where you will be passing the key value, and this key value where it is available, so that position, that node, you have to delete it. So you create a location and you create temp, two pointers. So location is equal to search of key. So you will first pass this key to the search function and you find out where is this key is available. Whether it is available or not, first you will come to know. So if it is available, the location value you will get it. If it is not available, you will get null. Yes, if the location contains null, oh, it is understood. The element is not found, you just display element is not found. That's it. If the location is first, that means if you want to delete the first element, what you have to do is very simple. You check whether you have only one element. Whether first is equal to last. That means there is only one element. In that case, first is equal to last is equal to null. And delete the location, free the location. That's it. So everything becomes null. So gone, free location. And of course, if you say null, it is automatically you are removing. So free function may not be required here. So you just return it. Okay, you just return from the program. Now, if it is not the first one, if it is not the only element, you have some more elements, but you have to delete the first element. In that case, you move the first pointer to the next, first of next, last pointer, next you have to move it to the first. So since it is moved, so there is no need. And later you can certainly delete the LOC, the location pointer where you are having value, that you can just return it, delete it and return. If not, if it is in between, you start from the temp, you go up to the location, that is temp is moving to the previous of location. There is temp of next is not equal to null. Next not equal to null means you move temp to the previous of the location. So and that's it. You just move, you are moving temp to the previous of location. That's all. This for loop is doing only this operation. It is moving temp to the previous of the location. Now, if the temp is, if the location is last, then what you do? Very simple. Last is equal to temp. So last is equal to temp. Temp of next is equal to first. So that's the thing. So if the element that you have to delete, if it is a last, what you have to do? The previous of last, you move it to the first. So connect it to the first. If it is not, so temp of next is equal to location of next. So and finally you can free up the LOC, that is location, and you can return. So this is the function for deleting the element. The same it is there. So we can certainly execute. I'll just execute the same thing. You can see, yeah, I'll first insert some elements, 12, I insert one more, I insert one more, 34. Now observe now, so there are 3 elements that I have inserted. I'll insert one more, so 45, I insert one more, 67. Okay, now let us display all these things. 4. So when I display 12, 30, 23, 34, 45 and 67. Now let me search for an element. So search is 3, 45. So 45, it is searching for an element 3, and I'm just giving 34. 34 element is found. You can see element is found. So 34 element is found, and will display 4. So 12, 23, 34, 45, 67 last. Okay. So 34 is already I have searched and it is available. Now let us delete 34. So 34, I'll just delete it. Okay, deletion is done. So now let us see the element. So 34 is gone. Similarly, let us search for another element, that is 67. So 67 is also found.
So we will delete 64. So 67, sorry, it is not 64, it is 67. 67 is also deleted. So and we'll display the element. So you can see first 34, I think 34 is gone, next 64 is removed. Like this, we can also remove the first element, and of course the first element is 12. So first element is also element found 12, and you are trying to delete the first element also, and it is done. You can see the first element was 12, and we could able to delete it. So since we deleted first element 12, so it becomes 23, 45, and that is last pointer, and 23 is pointing to the first pointer. Similarly, you can delete another element, that is 45. Yes, 45 also it is deleted. Another element also I can delete. So that is if I delete 23, yes, it is also deleted. Now if you display, definitely it is showing a message, circular linked list is empty. You can see circular linked list is empty. You can see here circular linked list is empty. So this is how you can insert an element, you can search for an element, you can delete, you can also display the entire linked list, circular linked list. This program is very, very important. I'll share this program in the group. So certainly you have to practice. See, all these programs are very big programs until you have very good practice. So this program is around 120, 125 lines. Oh, sorry, it is moving beyond 150, 160 lines. So unless you have understood the program, unless you have practiced well in the examination, it is highly impossible to write. So keep in mind, so you have to practice well all these programs, so then only you can able to write it. So that's most important thing that you should never forget. So I'll share this program in the group, so you can certainly download this program and practice well. In the next class, we'll discuss about double linked list. Double linked list we have to discuss, and again all these programs, insertion of linked list, single linked list, circular linked list, double linked list, these are all very, very important programs. So you have to understand whatever it is given in the textbook, only those programs you practice very well, that is more than sufficient. And that's all for today's class. Thank you. All the class recordings are available in this particular website, and of course, have a wonderful day. Please type in your USN in the chat box for attendance sake. Thank you.